I'm going to be honest. Collisions are pretty tough. Elastic collisions are double tough. Elastic collisions in 2 dimensions are triply tough. Okay, but we can still use some basic ideas to figure some stuff out. And I actually am giving you some useful stuff here to make it as easy as possible. So here's the situation. I have these 2 balls in space, or asteroids, or whatever you want to call them, and they have the same mass, and the ball A is moving towards ball B. It's not a direct hit. It's kind of a glancing hit. But ball A has an initial velocity of 200 meters per second. They both have a mass of 1 kilogram, just for fun. And then after they hit, ball A recoils off. It's an elastic collision. It recoils off at a 50-degree angle, and then ball B recoils down at a 40-degree angle. So what are these speeds? Can we find these speeds? And you don't even really need V1, but let's just see what we can figure out. Okay, so if it's an elastic collision, I actually have 3 equations. The first equation I have is the kinetic energy is conserved. It's an elastic collision, so the kinetic energy of this stuff before is equal to the kinetic energy of this stuff after. So let me write that equation. So let's say K1 equals K2. So this is going to be 1/2 ma va1 squared plus the kinetic energy of this one, which is 0. I'll put plus 0. Equals the final kinetic energy, 1/2 ma va2 squared. Va2 is the velocity afterwards, plus 1/2 mb/v2 squared. Now, I just want to be clear, this is the magnitude of the velocity, so really I should say va2 squared is equal to the magnitude of va2, all of that squared. So, because that's a vector, right? You can't square a vector, so. Okay, so that's one equation. It's so important that I'll put a purple box around it. See? So you know I'm serious, right? Purple box. Okay, now the other equation I have is P initial equals P final. The total momentum is constant because in all collisions where there's no external forces, the momentum has to be conserved. Now this is a vector equation. So it's actually easier to write this as 2 scalar equations. So I'm actually going to write this as the 2 equations, P1x equals P2x, and this is initial and final total, and then P1y equals P2y. So I actually have 2 equations. So let me write this first one. The initial x momentum is going to be ma va1 plus 0 equals, now let's look over here. Here's my diagram. There's va2, the magnitude, and that's the angle. This is the x component of the velocity, va2x. So that's what I need. So if this has a velocity va2, this would be va2 cosine theta, right? Because it's the x component. So this is going to be, and this is positive because it's in the positive x direction. I didn't put my x-axis, x, y. Okay, so this is going to be ma, the va2 cosine of 50. Now I need to do the same thing for the second mass. So it's going to be plus. It's also in the x direction. It's going to be mb vb2 times cosine of 40. There you go. Should that get a purple or red box? Let's just do purple. That's an important equation. Okay, now I can do the same thing for the y direction. So what's the initial y momentum? Well, it's not moving in the y direction, so it's 0. And then that one isn't either. And then afterwards, I deal with this, the vertical component, the y component of a2 is going to be va2 sine theta, because it's the opposite side. So it's going to be ma va2 sine of 50. Now for b, then it's going to be sine of 40, but it's also going to be negative, right? This is in the negative y direction. So I get minus mb vb2 sine of 40. Yep, purple box time. So let's think about let me do the following. Stuff cancels. Okay, and I made it that way so it's easier. Because since MA is equal to MB, MA and MB, this is in every term, so I can cancel, cancel, cancel. I can also cancel the 1/2. So I get a slightly simpler equation. Down here, the m's all cancel, 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 cancel. Okay. Now, how many equations do I have? Well, that's easy. I have 3. 1, 2, 3. How many variables do I have? Well, how many things do I not know? Let's say I know VA1. I gave that to you. I don't know this one. I don't know VA2. I don't know VB2. I don't know VA2. Again, I don't know V. These are magnitudes. So I have only 2 variables that I don't know. That's a good thing, right? That says that I don't need 3 equations. If I had 3 variables, I would need 3 equations. But I have 2 variables, so I only need 2 equations. So let's go ahead and solve some stuff. Let me go ahead and I'm trying to think the best path here. I mean, I definitely want to use this one, right? Because it only has, it's simple. And I think I can just use this one. I'd rather not use this one because it has a square in there. I think I can solve everything just with this. And so let's do that. So let's solve this one for VA2 and then plug that in down here. So I'm gonna rewrite this equation right here. So I get VA1 equals VA2 cosine 50 plus VB2 cosine 40. And these are just numbers, right? So that's cool. And that's a number too. So that's actually, I should put, this is VA2x. So I'm going to go ahead and put 2 there just so it makes it look a little bit nicer. So I want to solve for VA2, so I'm going to subtract this from both sides. I get 2 minus VB2 cosine 40 equals VA2 cosine 50. And then I divide both sides by cosine 50, and I get VA2 equals 2 minus VB2 cosine 40, all of that over cosine 50. Now I can plug that in to this equation and solve for, let's just plug that in. So I get 0 equals VA2, but instead of VA2, I'm going to put this stuff. So I'm going to say 2 minus VB2 cosine 40. All of that over cosine 50. That's that part. And I have to multiply by the sine of 50. And then I have to subtract. That's all. That's fine. Subtract VB2, which I will have right there, sine of 40. Okay, so now I only have one variable in this whole thing, right? I'm going to first multiply both sides by cosine 50, and I still get 0. And I'm going to add this to both sides. I know I'm skipping steps, but I just want to. So I'm going to get VB2 sine of 40 cosine of 50 equals 2 minus, actually still have that there, 2 minus VB2 cosine 40 sine of 50. So this is multiplied by that 2 also, which is just a number. Okay, so now I'm gonna multiply this out, and I get 2 sine of 50 minus VB2 cosine 40 sine of 50. Now I can add this to both sides and factor out this stuff. So factor out the VB2. So I get VB2 times this stuff, sine of 40. I'm going to leave off the parentheses. Cosine of 50. And that's going to be plus cosine 40 sine 50 equals 2 times sine of 50. And yeah, this looks bad, but these are all just numbers. It's really not too bad. So that's just a number, and I can divide that by that, and I get VB2 equals 2 sine 50 over sine 40 cosine 50 plus cosine 40 sine 50. Now it's calculator time. Okay. So let me get my calculator out right here. And drop. So I'm going to do this. This is up here. 2 enter 50 trig sine times. That's the top. Now I'm going to do sine of 40. 40 sine. And then I'm going to multiply by 50 cosine. 50 cosine times. So that's that number right there. Now I need to get this number. So it's going to be 40 cosine. I feel like I'm going to make a mistake, but 50 sine times. Now I need to add those two together. Now I need to, this is 1, and then I need to divide that, and I get 1.53. And there's a reason that's 1 meters per second. That's the magnitude of the velocity for VB2. Now I can go back over here, up here, and solve for VA2. So it's going to be 2 minus 1.53 times cosine of 40, all of that over cosine of 50. And let's put that in my calculator. So I'm going to get, I have that number right there. I'm going to multiply by cosine of 40, 4d cosine times, and then I'm going to make it negative, and then I'm up here. Then I'm going to have 2 plus, and then I'm going to divide by the cosine of 50. 50 cosine divided by, and I get 1.29 meters per second. And I am rounding. Okay. So there's my 2 answers. They're so important. I'm going to put them in red. And I skipped on. Okay, so I'm done, really. But let me go back and just check. This should be true, right? This equation should be true from kinetic energy. So I should be able to say VA1 squared equals VA2 squared plus VA3 squared. And so I know what this is. This is going to be 2 squared, right? So that's 4. So if I square these two and add them, I should get 4. Let's just check. It won't be exact, also because I possibly made a mistake. But let me put in this number right here. So 1.29 squared. And then I'm going to put this one in, 1.53 squared. And add them. And I get 4. I know I was kind of scared when I pushed that because I'm like, well, maybe I made a mistake. And I got 4.005 because I rounded. That's fine. Now, here's the one thing that I do want to tell you. There is a trick here. This angle between VA2 and VB2 has to be 90 degrees if it's an elastic collision. Now, I can't remember if the masses have to be the same or not, but if the masses are the same and it's an elastic collision, when they recoil, it has to be equal to 90 degrees. But the problem with this is that you can set up all of these equations. You have to pick which ones you want to solve to get what you want. And you have multiple options here. You could have done it this way. It'd just be a little bit more complicated. So, and then once you get down here, these are just numbers. I wrote them as cosine 40, sine 40, and stuff like that. But those are just numbers. So don't let this problem intimidate you. You're better than that. Okay? You intimidate the problem. Yes, it is confusing. I said that from the beginning, so I'm not at fault there. Okay. There you go.